Hello, everyone. So you got another look at the unit circle just now, in trigonometry 005, we covered the graph of the cosine function. In trigonometry 004, we covered the graph of the sine function. Now I'm going to do the graph of the tangent function. We're going to take a break from there. We're not going to go into the graphs of cotangent, secant, and cosecant. We can do that in the exact same ways that you see I do here. But right now, what I'm going to do is I'm going to go through this graph of tangent, and then we're going to start working on some identities. So I think you'll be able to make some sense of some of the more pressing things that you run into in a physics class or a chemistry class or just in your trigonometry class and trying to do identities. So let's get started with the unit circle and making a table of y versus theta values for tangent. I'm going to use the same table I did before, so you'll see it all there. But I'm going to use something as well that's slightly different. So let's get you to my document cam. So if you look here, you'd actually have to find tangent, it's opposite over adjacent. So it'd be a little bit problematic, but really, if I go back to a couple of identities that we learned from the very beginning, sine theta was opposite over hypotenuse, which on this triangle is, whoa, I wrote those backwards. So let's scratch that real quick. I did it just on the fly, so that was clearly a mistake. I labeled them this way, but in my brain I had them set this way. So this is B over C. Adjacent is A over C. And then tangent is opposite over adjacent, which is B over A, and I did do that one right. So with that in mind, that's really all you need to know. You can say, wait a second, what if I divided sine by cosine? Well, sine's opposite over hypotenuse, cosine's adjacent over hypotenuse. Dividing by a fraction is the same thing as multiplying by its reciprocal. So the hypotenuse comes on top, the adjacent comes on the bottom, and you're just multiplying. With the hypotenuse up here and the hypotenuse up here, those cancel out and you're left with opposite over adjacent, which is in fact tangent theta. So really all I have to do is divide the sine theta by the cosine theta. Or if you look on the unit circle, remember y is sine and x is cosine, so you can do y over x, which is in fact the slope. So I just do 1/2 over root 3 over 2 for pi over 6. I do root 2 over 2 over root 2 over 2 for pi over 4, so on and so forth. I'm going to go with y over x. So let's get that started. Y is, of course, sine theta, and x was cosine theta according to the unit circle. So I'm just going to do this divided by this. So from that, we get that the tangent of 0 radians is, of course, 0 divided by 1, which is 0. The tangent of pi over 6 is 1/2 divided by root 3 over 2. So that's 1/2 times 2 over root 3. So that'd be 1 over square root of 3, which we should really make root 3 over 3, just to make it rational. Sorry about that messy looking 3 there. Now root 2 over 2, that's the that's pi over 4. Root 2 over 2 is just going to give us 1. Pi over 3, we're going to get root 3 over 2 divided by 1/2, which is the same thing as root 3 over 2 times 2, so that's just the square root of 3. Pi over 3 is going to be difficult. In fact, we see that it's 1 divided by 0, so this one's undefined. Okay. Now, if you start to look the other way, if you start to look for the negative side, and there's a reason I know what's going on here, I actually know what the graph is, but if I start to go to my tangent of negative pi over 3, so if I did negative, well, 0, we already got that, but negative pi over 6, remember, tangent of negative pi over 6 would just be the tangent of this, right? So this is negative pi over 6, and that, of course, is just y over x, so that's negative 1/2 divided by root 3 over 2, which is the same thing as negative 1/2 times 2 over root 3, which would be negative 1 over root 3. So we can see when theta is equal to negative 0, we still get, of course, 0. When theta is equal to negative pi over 6, okay, then I get negative of what I had for tangent theta, because the difference is I've changed the x, or excuse me, the y with the negative y and left the x the same. So that's going to become, as I showed you on this, negative 1/2 divided by root 3 over 2. That's negative 1/2 times 2 over root 3. So that's negative 1 over root 3, which is negative root 3 over 3. Now, if I do pi over 3, I think that's the next one. Yeah, if I do pi over 3, I want to go to this guy right here. And pi over 3, y over x gives me negative root 3 over 2 divided by 1/2, which is negative root 3 over 2 times 2. So that's just negative root 3. And of course, we'll find that, again, the negative of this y over x be negative 1 over 0. That is, again, undefined. So I did my table a little differently because the trig function for tangent looks significantly different. So let me, now that I have those points, believe it or not, that's really enough. Now let me share my screen and we will go to DesMos again and let you see the graph. So DesMos, I already had cosine right here in the green. I got tangent right here, or excuse me, I got sine right here in the bluish purple color. Now, if I want to do tangent theta, it's going to look remarkably different. I can go ahead and get rid of these dots. And I want to put in some other points. Let's put in 0, 0, which we know. So parentheses 0, 0. So I got that point. The next point I want to go to is root 3 over 3 with pi over 6. So I'm going to do parentheses pi. I'm going to copy that, guys, so I can use it again. Control C. Over 6. Get out from under there, comma. And pi over 6 gave us root 3 over 3. So I'm going to say square root 3. Get out from under there, comma. Nope, get out from under there, divide by 3. Get out from under there. I said get out from under there. Parenthesis. And that gives me the next function, or the next point. And now the next one is pi over 4, and that should give me a value of 1. So 0, control V, divided by 4, get out from under there, comma, 1, parenthesis. Look how much steeper that is. We're going to have to obviously change our range a little bit more. And in fact, let me change this from the y-axis being from -2. I'm going to change it to being y-axis. I'm going to change to -10 to +10. Whoa, that's some crazy stuff going there. Okay, now I can start to see there's my cosine again in green, there's my sine again in purplish, bluish, whatever color that is. And now I can do the next value, which is pi over 3. So parenthesis, control V, divided by 3. Get out from under there, comma. And that value, pi over 3, is going to give us square root of 3. So I'll just do square root 3. And lo and behold, I get that graph, that point. And let's do the next one, which is 90 degrees is undefined, so we can't do anything with that. So we can't do anything with pi over 2. I could get a little closer by making various estimates and stuff like that. But now it's time I'm going to write y equals tangent x. And you see what happens. So this is why the right-hand side is just the negative of the left-hand side, as we found in our points. We got the same value, but a negative y for that one, the same value, but a negative y for that one, the same value, but a negative y for this middle guy, and the same value, but a negative y for this guy. And in fact, there's an asymptote at pi over 2 because this is approaching infinity as you get closer and closer to pi over 2. Similarly, as you get closer and closer to pi over 2, you approach infinity in the downward direction. So that's the actual graph of tangent. Now, if you go beyond pi over 2, let's stop sharing the screen just a second. First off, I'm going to kill this so you can see the actual beauty of this graph. So you can see the graphs of tangent. You can also see that tangent is very close to sine for a good chunk of its initial angles, negative and positive. But looking at that graph, you can now see the various tangent graphs. But let's see what happens. I'm going to stop sharing. I'm going to look at our table. So when we got to pi over 2, that was undefined. But then when you go to, of course, pi over, or let's say 2 pi over 3, that's bigger than pi over 2. And in fact, if you do y over x, it's root 3 over 2 divided by negative 1/2. Root 3 over 2 divided by negative 1/2 is the same thing as negative root 3 over 2 times 2, which is just negative root 3, which I think you can see is just like what we got for 60 degrees. And then you can see that again. After that, you can go an additional angle, say to 3 pi over 4. And 3 pi over 4 is basically y over x, so it's root 2 over 2, negative root 2, or positive root 2 over 2 divided by negative root 2 over 2, so that should be negative 1. So we're actually going to get a negative 1 when we're that far past it, and so on and so forth. But doing this will allow us to actually get the other individual points. Similarly, the negatives we can just get from, as I did before, going down here to get the pi over 6, the pi over 4, the pi over 3. But now I go past negative pi over 2, and I just start getting these values again using y over x as, and this is y and this is x, as the individual values. And I think you can see, once I share screen again, you can see what happens. So when I go, for instance, to, let's see what this value is. That value is 1.775. That's not really that helpful to me. Let's look at the 1 value. So I got 1, 2, 3, 4, 5. So each of these are 1 unit. This 1 is about 0.79. And if I look over here and I see this 1, which is about negative 1, which is about 2.36, you can see it's past 2 pi over 3, but this distance from here to here should be exactly the same as this distance from here to, where's the 1 at? To there. So whatever this was, that's our 1 value, or no, that's our 1 value. Yeah, that's our 1 value, pi over 4 and 1. So if I went over here, pi over 4 beyond pi, then I should get 1 again. And that is occurring roughly here. And that should be pi over 4 plus basically pi, and so on and so forth. So from doing that, we can just repeat these graphs forever and ever, just in a cyclic way, using the unit circle. So I hope that helps you with the tangent. Now, to get the graph of the cotangent, you now flip those over. So you take it and find the reciprocal of each of the tangent y values and graph that. And to get the secant, you take the reciprocal of the cosine, and to get the cosecant, you take the reciprocal of sine. So let me just quickly get rid of all of these and just show you what those other graphs look like, and let you try to work out the points yourself. So I can do y equals cotangent x. There's that. So you see, it sort of looks like the tangent, except where the tangent was infinity, you can actually have values. You can have cotangent of pi over 2, because instead of it being 1 over 0, it's 0 over 1, which is 0. But now you can't have zeros and pi's and so on and so forth. I can also do y equals secant x, which is 1 over cosine, and you get these weird things. Notice they come as close as they can to 1 and even barely hit 1, but then they take off back up again. So they never get any lower than plus or minus negative 1. So they're always lower in value than negative 1, or higher than value than positive 1. And then finally, you can do y equals cosecant x. And you see that's like the secant x, but it's shifted sort of like the tangent and cotangent were. It's been shifted, as is the sine and cosine were shifted as well. So they've been shifted by pi over 2 again. So I think that's a pretty good intro to the graphs in general and how to do them. I've sort of explained everything you need to know about how to do them. And I think that's a really good intro to the basics of trigonometry, basically via Trig 001, 002, 003, 004, 005, and 006. I hope that helps you guys, and have a good day.